Good evening, everyone. Today I'm going to start a small topic on which your assignment will be based. It will be related to the devices which we are going to use in the network. So one of them is Ethernet switch, and the another one is your router. So Ethernet switch is a link layer device. We are going to study about link layer as we go on. So it takes an active role. It uses store and forwarded Ethernet frames, examines incoming frames MAC address. The MAC address is basically, you can say, the address given to the device when it was manufactured. So it's medium access control address, which is fixed for every device. The only address which is flexible, or you can say which keeps on changing, is your IP address. So it selectively forward frame to one or more outgoing links when a frame is forwarded on segment. It uses CSMA/CD to access segments. CSMA is carrier sense multiple access, and oblique means CD is your collision detection. So it detects the collision and it tries to avoid the collision. So CSMA is carrier sense. So if someone else is sending the message on the same link, then it try to sense if someone is sending or not. And if there is someone else, so it's try to do the collision detection. It's the nature is transparent. Hosts are unaware of presence of switches. So when you are using a laptop or a desktop, you are not aware you are using a network, whether it's having any switches in the network. It works on plug and play, self-learning. So as the network sent message from one side of the network to the another one, it usually decodes their MAC address, IP address. So this is what self-learning means here. So switches do not need to be configured. Switch when you have multiple simultaneous transmissions. So consider a network like this. So suppose I have one host here as A, another one as A dash. A is connected to a port. We are using a switch with port 6. So there are six ports to the switch. So C dash is connected to 6, B dash is connected to 5, and B is connected to 2, C is connected to 3. So you can say switch with 6 interfaces, 1 to 6. So hosts have dedicated direct connection to a switch. So every host which is connected to the switch has a dedicated line connected to it, or you can say dedicated connection to switch. Switches buffer packets also. So if some packets comes to the switch from maybe from a host, and there is a congestion here, so it can buffer packet for some time. Ethernet protocol used on each incoming links, but no collision. Full duplex, so it works on full duplex mode. Each link is its own collision domain. So the collision domain, when I'm saying collision domain is the domain or the part of the network where there are chances of collision. So this is a one collision domain, this is another collision domain, this is another collision domain. So it depends on the link. Switching A to A dash. So A to A dash switching and B to B dash can transmit simultaneously without collision. So suppose a user, or can say host, wants to send a packet from A to A dash. So there's no collision, because when a packet will arrive from A on this port of switch will look at the MAC address and it will see that this device or host is connected to my link, port 4. So it will transfer the information, or you can say packet, from this side to this side directly, looking at the MAC address of the device, because that device is connected to itself. In a similar way, if someone wants to send from B to B dash, then it will be transferred directly, because here there's no collision. Why? Because they are just using one packet which they are sending from this side to this side. So it's not like that A and B are sending a packet together at the same time to A dash. So there will not be any collisions. Switching, how switch works on a forwarding table. So how does switch know that A dash reachable via interface 4, B dash reachable via interface 5? A. Each switch has a switch table, each entry. So whenever a host gets connected to the switch, switch learns its MAC address. So MAC address of host, interface to reach host, and timestamp means time to leave, in how much time the packet or you can reach the host. So it looks like a routing table, which the routing table is a term which is used mostly for the router. But the switch work on the link layer and router works on a network layer. So it uses IP address also. So when we talk about router, the router uses IP address, but switch uses only MAC address for sending the information. So how are entries created, maintained in a switch table? It works something like similar to your router, but it works entirely different because it works on MAC address only. How a switch does the self-learning? So switch learns which host can be reached through which interface. When a frame received, switch learns location of sender incoming length segment. So suppose this host is sending the information, so it will attach its own address, which will be might be including your IP address, but it must be including the MAC address. So there will be an IP address, there will be a MAC address. So when the information will come to this port, then the switch will learn the information of this host also. So record sender location pair in switch table. So it will record the MAC address. So switch uses MAC address, so it will record only MAC address. But the packet contains the IP address also, which is used primarily by the routers. So, and there will be a time to leave of the packet. Time to leave means for how much time that packet can exist in the network. If that time passes and it doesn't reach to the, the port where it is supposed to be reached, then the host has to send that packet again. So switch frame filtering and forwarding. When a frame received at a switch, so it works in this way, that it records incoming link, MAC address of sending host, index switching table using MAC destination address. So it will look at the destination address MAC address of the destination, or you can say the MAC address of the host where the device where it needs to reach. So if entry found for destination, then if destination on segment from which frame arrived, then drop frame. So if the segment, or can say the packet from which it has been sent, the destination address is also same, then the packet will be dropped, or you can say the frame will be dropped. Else forward frame on interface indicated by entry. And if it sees that the frame is the destination of the frame where it is supposed to reach, it's in its table, then it will send it to the particular interface. Else, so if the switch doesn't have any information, that is the main drawback of the switch. So if switch doesn't have the information where that particular user, or you can say host is, then it will send that packet to all the ports. So this is the main disadvantage associated with the packet, switch, that it will send the information to all the ports except the port from which that packet arrived. So it's basically create an excess, or you can say extra load on the network. So this is the drawback of the switch. Now self-learning, again forwarding example, frame destination A dash, location unknown. This is an example of flood. So if the location of A dash is unknown to it, so there's no communication happened between switch and A dash, and before that time A wants to reach A dash, then switch is we're not aware of the location of 4, even though it's connected by with the help of a wire. It's not aware of its location. So it will do is it will send the packet to all the interfaces, and when one of these will say that I'm the A dash, then it will record the information. So destination A location known, selectively sent on just one link. So if it knows where it needs to be sent, then it records it. It sends it to that particular interface. If it's not known to it, then it will send to all the interfaces. This is the main drawback with the switch. Interconnecting switches. So if you there is, I can say, hierarchy of switches connected to each other, and they are connected in this way. Sending from A to G, how does S1 know to forward frame destined to G via S4 and S3? So whenever that information will come, so in this way, in this, basically there are collision domains which are created. So this is one collision domain. So if S1 is not aware of any of the host, so it will send the information to itself, and suppose the information is coming from this side, then it will send it to all these hosts. And if the information is coming from here and it's not aware of the location of the destination where it needs to be sent, then the switch will send it to these two and this one also. Then it will reach on this one. So if S4 knows that where this packet needs to be reached, then it will send that to that particular location, else it will again forward it to this one also and this one also. So it keeps on going until it knows the location of the user or the host. So sending from A to G, how does S1 knows to forward frame destined to G via S4 and S3? So it works on self-learning. So once the first packet, can say, will be used for self-learning, and in sending that packet, it's basically increasing the load on the network. Sorry. So multi-switch example. Suppose C sends frame to I responds to C. So what will happen is that C sends to frame to I, C sends the frame to I. S1 is not aware of the location of I, so it will send it to all the host connected to it, or you can say the another switch connected to it. The information will go here also. This switch will send it to both the switches. If it doesn't know. If it knows where I is, then it will send it to this side only. So the information will not travel on this S2 switch. It will just travel on S3 switch. But if it doesn't know, then the information, or you can say the packet, will be sent to them also. However, when they see that the MAC address is not known to them, then they will discard it. And in a similar way, when it keeps on going through these things, then it learns where a particular host is currently, and then it updates its table. Institutional network. So in a similar way, if you see, there will be a router. If I compare it with the CPUT, there will be a router connected to the external network, or you can say the internet, and we have own our internet. So there will be a mail server of CPUT, there will be a web server of CPUT, and then there will be, you can say, we are using a switch here. So this switch will be connected to different switches, and maybe one of them is for library, maybe for electrical department, maybe library has multi divisions also, like let's say electrical department has multi divisions also. So for this purpose, we buy IP addresses, and there's a term which is used with it, which is called as subnetting, and we get a subnet. So if you remember, whenever you enter an IP address somewhere, you also like in LAN settings, which you might have done on your computer, there is a place for IP address to enter, and then there's a place for your subnet to enter. You might have seen it something like 255.255.255.0, or sometimes it's 255.255.0.0, or it is 255.0.0.0. I'm going to give you the assignment on the basis of that also. So after this video, I'm going to upload another video which will be explaining the meaning of subnetting what is the meaning of your 255 there. So I want you to know a bit of binary numbers before you start looking into that. So you must know that how many bits in one byte. You can say it's 8 bits. So if I write an 8-bit number, so what's the meaning if there's a 1 at the most significant bit? What's the meaning if there's a 1 at least significant bit? So the most significant bit means that it is 128, least significant bit, that means 1. So that complete, if you add all those 8 bits, sum of all those there, they are 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that comes out to be 255. So that is that 255 there, and how it has been used I'm going to explain in the next video. But why we do subnetting? Because it's not possible for everyone to buy too many IP address. So the university or any organization, they just buy 2 or 3 IP address, and then they do subnetting to increase number of hosts. So if you remember, like we have computers in labs, we have computers used by staff members, we have computers used by library. So there's usually 1 or 2 IP address which are subnetted in that way that they form a different IP address. They looks like we are working on a different IP address, but they are basically subnetting. There's a subnetting which is done to increase the number of IP address locally in internet. So these are hosts are included into the system with the help of subnetting. Now what is switch? I explained. Now if I compare it with the router, both uses store and forward, means on a router also you can store the packets for some time and you can forward. So if the information, if the outgoing link is free, the router or switch, both of them looks into the table, they send it to the destination. If that is busy, then, or you can say there's a collision there, then they can store it for some time. But router works on network layer. So it works on network layer, so it uses the network layer header. Switches, they are link layer devices, so they work on link layer, data link layer. So both have forwarding table, router using a routing table, which included your IP addresses also. And switches learn forwarding table using flooding. So switch learn the location of a user by initially flooding the network, and then it learns it and it works on MAC address. Routers compute tables using routing algorithm and IP addresses. So they use routing algorithm to learn the location of different users. And switches separate the network in the form of your collision domains, and router usually reduces the load on the network by not flooding it. So I'm going to explain how subnetting works in my next few lectures, and then I'm going to give you an assignment which will be based on it. So please go through it. Just try to make a sense how the devices which we use in our daily life, switch and router, how they are same and how they are different from each other. Here also you can see on this, here also switch is here. So it uses link and physical layer, so it's work on link layer, and it works on the network layer. Thank you.